Hello, good morning, everyone. Uh, Today, in this class, we're going to deal with class 7 mathematics exercise 3. And this very chapter, deal with rational number. You can see here already the title of the chapter is mentioned. So, this chapter deals with rational number. Well, before proceeding into solving different problems related to rational numbers or proceeding to the exercise, that is first highlight or that is first recap whatever we have already learned in our previous classes in class 6, class 5 regarding rational number. And one more thing, in order to clear the concept of rational number, one must have the clear concept of what called integers, whole numbers, natural numbers. These basic things are related with one another. Okay. In order to know rational number, we must know what is an integer. If we don't have the clear concept of an integer, or it will be problem for us to understand rational number. Well, before knowing rational number, let us first know what is an integer. Okay. So integer, integer. You know, it's integer. So the very term integer includes all the natural numbers, their negatives, along with zero. Okay. So integer is an idea, is a concept which includes all the natural numbers, their negatives, along with zero. Now, what is natural number? What is natural number? Okay. The counting numbers are called natural numbers. Natural number is the counting numbers, and the natural number begins from 1. Natural numbers begins from 1. 1, 2, 3. What is the natural number? Okay. 1, 2, 3, 4, 5. This is called natural numbers. These are counting numbers, and counting numbers are called natural numbers. And natural numbers begins from 1. 1 is the first natural number. Okay, the least, or you can say the first natural number is 1. So when it's a natural number, it does not include zero. That means zero is not a natural number. Well, and what is the natural numbers? The negative numbers, say 1, minus 2, minus 3, these are also not included. These natural numbers start from 1, 1, 2, 3, 4, 5, 6, like this. It's proceed on, and there is no greatest or highest natural number. Okay, smallest natural number is there, that is 1, but there is no highest natural number. Natural numbers begins from 1. Counting numbers are called natural number. Well, now let's see. When we say integers, okay, it includes not only the natural numbers. Along with the natural numbers, it includes the negative idea or negative concept of natural numbers. That means 1 and the reverse of 1, negative of 1 will be minus 1. 2, negative of minus will be minus 2. 5, negative of 5 will be minus 5. So this what called natural numbers and their negatives all together we say integer. But again, when it's a natural number, we don't include the zero. Zero is not included. Okay, zero is not a natural number. But when it's an integer, it includes 0 too. So if you summarize what is an integer, so we can say all the natural numbers, their negatives along with 0 are said to be integers. Okay. So we are not going to learn here integers, we are going to learn rational numbers. So before learning rational number, one must have the clear concept of integers. So unless having the clear concept of integers, one will not understand the natural rational numbers. So I've just mentioned here what is an integer. Now let us proceed to the rational number. Well, you can see the definition here. Rational number. A rational number is a number which can be expressed in the form of P by Q where P and Q are integers, but provided that Q not equal 0. That means Q cannot be 0. So here we've got three conditions here. To be our rational number, we've got three conditions. Condition number 1, it should be in the form of P by Q. Condition number 2, okay, this P and Q both must be integers. And condition number 3, that Q must be 0. Q cannot be 0. If these three conditions are fulfilled, then and there only a number will be considered as a rational number. Well, let's see. It should be in the form of P by Q. Okay, P by Q. That means if we say in a fraction we have got numerator and denominator. Rational numbers rational number is not the synonymous of fraction. Fraction and rational number are two different concepts, two different ideas. But just to make you understand, I have taken the example of fraction. A fraction and rational number are fraction and rational number quite different concepts, quite different ideas. Both are not same. We cannot synonymous rational number with fraction. But still, let's see. When it's a fraction, see, in a fraction we got numerator and we get a denominator. Likewise, this we have got the bar, and the number lies above the bar is called P, and number lies below the bar we can call here Q. Okay, so it should be in the form of P by Q. All right, that is the first condition. Condition number 2, this P and Q both should be integers. That means integers means what we know. We know that any positive natural number, any natural number and their negatives along with 0. That means P can be 1, P can be 2, P can be minus 1, P can be minus 2, P can be 5, minus 5, 0, anything. And Q also an integer. So Q can be 1, 2, 3, minus 1, minus 2, minus 3, anything. But remember, Q cannot be 0. That is what given in the definition of rational number. That means, say for example, if you write here now 2 by 3, okay, if you write 2 by 3, whether 2 by 3 is a rational number, whether 2 by 3 is a rational number, okay, in order to know whether 2 by 3 is a rational number, let us observe the number, okay, let us observe the numbers, let us verify it. So, condition number 1, that it should be in the form of P by Q. Now see, 2 by 3. This is, you have got bar. Above the bar you have got 2 and below the bar you have got 3. That means here P is 2 and Q is 3. That means it is in the form of P by Q. First condition fulfilled. Condition number 2, P and Q are integers. Is it? So here P is 2. Here we have got P is 2. P is 2, since we know that 2 is an integer. Since P is 2, it is an integer. Then Q is 3, and 3 is also an integer. Since that means it is in the form of P by Q, and P and Q are integers. Now condition number 3. Condition number 3 what given? Q should not be 0. Q cannot be 0. Q must not be 0. Now here our Q is what? 3. Since Q is 3, Q is not 0. So we can conclude that 2 by 3 is an example of a rational number. I think you have got the idea what is rational number. Let us take one more example in order to illustrate it, in order to clear the concept. Let us take one more example. Say I've taken 0 by 5. Okay, 0 by 5. Now, whether this 0 by 5 is a rational number. Now let's see whether 0 by 5 is a rational number or not. By definition of rational number, what we know? We know that it should be in the form of P by Q. So here 0 by 5, 0 is P, here P is 0, it is in the form of C. 0 is P and 5 is q. Okay, so since it is in the form of p by q, our first condition fulfilled. Now let us the second condition, that p and q both should be integers. Now our p is here, p we got 0, and 0 is an integer. 0 is an integer. Okay, next q. Q we have got here 5, and 5 is also an integer. So our condition number 2 also fulfilled. Now condition number 3, that q cannot be 0. Yes, q is not 0, q is 5 here. Since q is not 0, q is 5, p and q both are integers, and it is in the form of p by q. So 0 by 5 is an example of rational number. But if you write 5 by 0, 5 by 0, whether it's a rational number, whether 5 by 0 is a rational number. So in this case, by observing the number itself, we can say that 5 by 0 is not a rational number. Why? Here condition number 3 is not fulfilled. What is the condition number 3? Condition number 3 is that to be a rational number, q cannot be 0, and since here q is 0, so 5 by 0 is not an example of rational number. Alright? Okay. Now we'll take one more example to clear the concept. Okay. Say root over 2 by 5. Okay. Root over 2 by 5. Whether root 2 by 5 is a rational number. Root 2 by 5 is not a rational number. Why root 2 by 5 is not a rational number? Because we call the definition that it should be in the form of p by q, and condition number 2, p and q both should be integer, and here our p is root 2, or p is root 2, sorry, p is root 2, and p is not root 2 is not an integer. Root 2 is what called sharp, it's not an integer. Since it's not an integer, so root 2 by 5 is not a rational number. Well, we can analyze a rational number some other way also. Okay, say for example, if you got 5 by 2, we got 5 by 2. So whether this number is a rational number or not. So in order to know, you can do another what you can do. We'll take the called numerator 5 as dividend and the denominator 2 as divisor. Okay. Now, having taken as divisor and dividend respectively 2 and 5, now we will perform the division. Now we will divide this 5 by this 2. Now see, if we divide 2 times 2 is 4, okay, remaining 1. Now if we put a decimal, for the decimal we got 0. Now 2 times 5 is 10. Now see, 10 minus 10 0. Since we have got the remainder 0, there is no more remainder is 0. Since the remainder is 0, that means it has been terminated, and such a what called decimal fraction, when after dividing we get the remainder at 0, such a decimal fraction is called terminating decimal fraction. Okay, since the operation has been already terminated, there is no remainder, it is called terminating decimal fraction. This 5 by 2 is a terminating decimal fraction, and all terminating decimal fractions are rational number. If you divide the numerator by denominator, and if we don't get any remainder, okay, and then in that case any remainder other than 0, if you don't get any remainder except 0, then it is called a terminating decimal fraction, and such decimal fractions are rational number. Okay. Okay, let us take one more example, that is 7 by 3. Well, now let us see whether 7 by 3 is a rational number or not. So in order to know what we'll do, we'll proceed the same process, we'll follow the same process. We'll take the numerator as dividend, I will take the denominator as divisor. Okay, now see what we'll do. I'll divide this 7 by this 3. Now what we can see, 3 times 2 is 6. Okay, remaining 1. Now you cannot divide 1 by 3, so we'll put the decimal, and from the decimal we'll get 0. Okay, decimal will lay 1/8. Out 10. Now 3 times 3 is 9. Okay, remaining 1. Then again from decimal we'll get one more 0. Now 3 times 3, 9. Again remaining 1. See, we are keep getting remainder 1. Keep getting remainder 1 and 1 and 1. See, repeat and repeat. We are getting remainder as 1. And here after decimal we are keep getting 3, 3, 3, 3. That means this 3 is repeating and the remainder 1 is also repeating. And such a decimal fraction is called repeating decimal fraction. So from here what you have learned, any repeating decimal fraction, okay, any repeating decimal fraction or recurring decimal fraction and terminating decimal fractions are rational number. And in reverse, on the contrary, the numbers is neither repeat nor terminate are called irrational number. So we are not going to learn irrational number here in this chapter. In later on in class 8 you are going to learn about irrational number. Class 8, class 9 you will get irrational number. So what is an irrational number? An irrational number is a number which neither repeats, okay, when you divide, perform the division, which neither repeats and nor terminates. Such decimal fractions are called irrational number. Well, with this I'm going to wind up this very class. Watch the following videos in order to get your solution of this very chapter. It's just you have to deal with the concept of rational number. What is irrational number? Till then, keep watching videos. Stay safe. Bye.